everyone. Our group will be discussed to you about the calculation of quartiles, deciles, and percentile of the group data. In this lesson, we were able to define quartiles, deciles, and percentiles. And we will also calculate quartiles, deciles, and percentiles for group data.
So let's define quartiles, deciles, and percentiles. Quartiles measures the spread of values above and below the mean by dividing the distribution into 4 groups. Deciles is those values that divide the total frequency into 10 equal parts. And percentiles are the measure that divide a group of data into 100 parts.
Good day, everyone. Today I will discuss to you about the calculation of quartiles for group data. But before that, let us define quartiles. So quartiles are the score points which divide a distribution into 4 equal parts. And they are: quartile 1 is the lower quartile, quartile 2 is the middle quartile, and the quartile 3 is the upper quartile. Here is the formula used in finding quartiles for group data. QK equals LB plus parentheses K times N over 4 because we are solving quartiles, minus CF sub N all over F sub QK parentheses times I, where LB stands for lower boundary of QK class, N is the total frequency, CF is the cumulative frequency of the class before QK class, F is the frequency of the QK class, I is the size of the class interval, K is the N quartile where N equals 1, 2, and 3. Let's say that this table is a group data table. This group is according to the scores of 50 students in mathematics class. And they are 21 to 25, 26 to 30, 31 to 35, 36 to 40, 41 to 45, and 46 to 50. So now let's solve for quartile 2. Here is the formula used in finding quartile. Based on the formula, we need to find for lower boundary and less than cumulative frequency. To solve for lower boundary, subtract 0.5 to the smallest number per class interval, and the lower limit are 21, 26, 31, 36, 41, 46. So let's subtract 21 to 0.5. 21 minus 0.5 is equals to 20.5. 26 minus 0.5 equals 25.5. 31 minus 0.5 equals 30.5. 36 minus 0.5 equals 35.5. 41 minus 0.5 equals 40.5. 46 minus 0.5 equals 45.5. To solve the less than cumulative frequency, just copy the first frequency from the smallest group. So the first frequency is 6, so just copy 6. And add the next frequency, which is 12. So 6 plus 12 equals 18. 18 plus 9 equals 27. 27 plus 11 equals 38. 38 plus 8 equals 46. 46 plus 4 equals 50. 50 because 50 students. We also need to get the interval and frequency. To get the interval, let's count 21 to 25. So therefore, the gap from 21 to 25, 26 to 30, 31 to 35, 36 to 40, 41 to 45, 46 to 50 is 5. So the interval class is 5. To get the frequency, just sum up 4, 8, 11, 9, 12, 6. So the total frequency is 50. This is the formula in quartile class. QK equals K times N divided by 4, where N is the total frequency, K is the N quartile, where N is equal to 1, 2, and 3. So let's substitute. K K is equal to 2 because we're gonna find quartile 2 times N. N is 50, the total frequency, divided by 4. So, 2 times 50 equal 100 over 4. 100 divided by 4 is equal to 25. We're gonna find 25 to the less than cumulative frequency. It must be greater than or equal to 25. So 25 is between in 18 and 27. We choose 27 because it's greater than 25. The quartile 2 is in the third last row. So, let's substitute in the formula, where lower boundary is equal to 30.5 plus parentheses where kn over 4 or qk class is equal to 25 minus cumulative frequency, that is 27, over f, where is 9, times I, where is 5. Copy 30.5 plus 25 minus 27 is equal to 2 divided by 9 times 5 equals 30.5 plus 2 divided by 9 is equal to negative 0.22 times 5 equals, copy 30.5 plus negative 0.22 times 5 is equal to negative 1.11. So, quartile 2 is equal to 30.5 plus negative 1.11 is equal to 29.3. So, our quartile 2 is equal to 29.3.
Everyone, today I will discuss to you about the calculation of deciles per group data. Here is the formula used in finding deciles in group data. D sub k is equal to LB plus quantity of kn over 10. So it is 10 because we are now solving decile minus less than CF all over the frequency of decile class times I, where LB stands for lower boundary of the decay class, N is the total frequency, less than CF is the cumulative frequency of the class before the decay class, I is the size of the class interval, F is the frequency of the decay class, and K is the position of the decile. So let's apply this formula in the example. Let's say we have this table. This is a group data table. This group is according to age from 10 to 12, 13 to 15, 16 to 18, 19 to 21, 22 to 24. So now we are going to find the decile 4. Here is the formula of decile. So based on the formula, we need the lower class boundary and the less than cumulative frequency. How to find the lower class boundary? Let's subtract the lower limits by 0.5. So here is the lower limits, the 10, 13, 16, 19, and 22. So let's have 10 minus 0.5 equals 9.5. Next, 13 minus 0.5 equals 12.5. 16 minus 0.5 equals 15.5.
19 minus 0.5 equals 18.5. And last, 22 minus 0.5 is equal to 21.5. We also need the less than cumulative frequency. So how to get the less than cumulative frequency? So copy the first frequency from the smallest group. So the frequency from 10 to 12 is 5. So copy 5, then add with the next frequency. So 5 plus 8 is 13. 13 plus 5 is 18. 18 plus 10 is 28. And 28 plus 2 is 30. We also need to get the interval and the total frequency. To get the interval, let's count from 10 to 12. So 10, 11, 12. So means the gap from 10 to 12, 13 to 15, 16 to 18, 19 to 21, 22 to 24. So the interval is 3. To get the total frequency, we need to add the frequency. So n is equal to 30. Next, we're going to find the decile class. Here is the formula in finding the decile class. Decile class is equal to k times n over 10. So let's substitute. K is 4 because it's fourth decile. N is the total frequency, which is 30 divided by 10. So 4 times 30 is equal to 120 divided by 10 is equal to 12. We're gonna find 12 in the less than cumulative frequency. So the less than cumulative frequency must be greater than or equal to 12. So 12 is in between of 5 and 13. So we're gonna choose 13 because it is greater than 12. Our decile 4 class is in the second class. Let's substitute now in the formula. Lower boundary is equal to 12.5 plus quantity of kn over 10, the decile class, which is 12, minus the less than cumulative frequency before the decile 4 class, which is 5, divided by the frequency of the decile 4 class, which is 8, times the class interval, which is 3. So let's simplify. Just copy 12.5 plus quantity of 7 because 12 minus 5 is 7. Just copy 8 and 3. Let's continue. 12.5 plus 7 times 3 is 21 over 8. Then 12.5 plus 21 divided by 8 is 2.625 is equal to 15.13. So decile 4 is equal to 15.13.
Good day everyone. I am Mary Ann B. a Zoology Ed Mathematics. So today I will discuss about the percentiles of group data. Percentile. Percentile divides the sets of data into 100 equal parts. The percentile of group data is used to characterize values according to the percentage below them. Finding percentile of group data is similar to that of finding quartiles and deciles of group data. In the same manner as calculating the quartiles and deciles, PK class is the class interval where the kn over 100 score is contained. In computing the percentile of group data, the following formula is used. So, P sub k equals LB plus kn over 100 minus less than CF over F times I, where P sub k is a known percentile, k has the value of 1 to 99, LB equals to lower class boundary of PK, N is the total frequency of data set, CF cumulative frequency of the class before the percentile class, F the frequency of the percentile class, and I is the class size or class interval. So, here is the example. Calculate the 65th percentile of the mathematics test score of 50 students. So, we have the 50 students and calculate the 65th percentile. So, first one is to solve 65th percentile. So, we have here the data and the formula to solve. So, first one to discuss is, it's all about the data. So, we have the 21 to 25, 26 to 30, 31 to 35, 36 to 40, 41 to 45, and 46 to 50. So, this is organized because 5 by 5, 21, 22, 23, 24, 25, and so on. Then, the frequency, that is the number of students correct each item from 21 to 25, 26 to 30, and so 6, 12, 9, 11, 8, and 4. So, how can we identify that the frequency is correct? If we add all the frequency, the summation is equivalent to 50 because the number of students is 50. If your summation or if your total is not equal to 50, so there's something wrong with your data or in our data. So, we have the column of lower class boundary and the less than cumulative frequency. So, we need to determine the percentile class. So, PC is equal to Kn over 100 because it's percentile. And the total frequency is 50. And this is equal to K is 65. So, 65 times 50 is equal to 3,250 divided by 100 equals to 32.5. So, now, how can we find the lower class boundaries from this distribution of frequency 32.5? So, the less than cumulative frequency is 38 and 27. So, that is in between of 32.5. So, as I said, we're gonna choose always the bigger number, 32.5, that is 38. So, the class interval of 38 is, that is 36 to 40. So, the lower class boundaries are 36 to 40, that is 35.5. So, we're going to substitute LB or lower boundary. So, 35.5 plus Kn over 100, which is 32.5, minus less than cumulative frequency, 27, over frequency, which is 11, times class size, which is 5. So, we need to solve first in the parentheses. So, let's copy the 35.5, the lower boundaries, plus, so, 32.5 minus 27 equals to 5.5. So 5.5 times 5 equals to 27.5 over 11. So, copy again 35.5. So, 27.5 divided by 11 equals to 2.5. So, 35.5 plus 2.5 equals to 38. So, the percentile of 65th is equal to 38. So, therefore, the 65% of the students got a score less than or equal to 38.